All right, let's go ahead and begin. Good morning. My name is Michelle. This is SIG-Apps. We are going to talk a lot about stateful apps today. So first up, we'll have a P.O.C demo of App Controller. After that, Prashant and Clayton are going to give us a little rundown about pet set beta steps. And after that, if Mike's on, he'll give us a demo of Nano Cube. So I won't hold us up anymore. Who's here to give us the P.O.C demo of App Controller?
I am. Hi.
Hi. Would you mind introducing yourself and telling us a little bit about what you're going to do?
Yeah, sure. Okay, so we have there's this issue on in Kubernetes repo about stateful app deployments, but it's not really only about stateful app deployments. Basically, it's about App Controller is about creating a deployment graph, defining it, and feeding it to the App Controller so it can create Kubernetes objects accordingly according to the dependencies defined. So with when there are some applications that have complex deployment graphs, then App Controller can actually deploy them, because otherwise it would need to be done manually. So what I'm gonna show is a little proof of concept that we made in 2 weeks. It's basically this App Controller is a pod that runs our binary written in Go, which checks Kubernetes API for two kinds of third-party resources: the resource definitions and dependencies. So we generate dependencies to specify the deployment graph. We feed the dependencies to the Kubernetes, so they are stored in Kubernetes. We feed Kubernetes object definitions into Kubernetes as third-party resources. Then we run the App Controller, and App Controller retrieves them and creates Kubernetes objects. So yeah, that's basically what I'm going to show. Can I start, or are there any questions before?
Does anybody have any questions?
Okay, maybe there'll be some questions after. Okay, I will share my screen now. Okay. Okay, can you see it? Can you see the graph?
Yes.
Okay, so basically, as I said, this is like really proof of concept. So right now in the deployment graph, there are only, in this particular deployment, there are only pods and jobs, but actually the App Controller can, with really not big effort, support all kinds of Kubernetes objects. So of course, replication controllers, because we don't want to spawn only bare pods. Maybe even pet sets. So we can actually have pet sets definitions for some stateful applications and use them as one of the nodes in the deployment graph. So the things that other Kubernetes objects that would depend on this particular pet set could be deployed after it's available. Okay, so this is how the graph looks like. There are two branches which are actually connected. So it's like here are several pods, several jobs. Each one of them each job will run for up to 20 seconds. Each pod will need to wait about 20 to 40 seconds for it to get ready. For now, we are using built-in readiness probe for this. So I will switch to pod definitions. So here are the third-party resources, right? Here on the right, we can see the dependencies. These are just this is only Kubernetes metadata. Parent and child is the data that is actually used. So we can see that this is pod, which will be named eventually a live pod, eventually a live pod 2, etc. This is the wrapped pod definition. It is wrapped into the third-party resource. As you can see, this kind is definition. This kind is definition, and the pod here actually holds all the data that we would normally use if we would like to use kubectl create -f and feed this there. So it is stored there, but it's not actually created until app controller decides that it needs to be created. Okay, so I have an empty Kubernetes cluster here. Here we can see the feed from get jobs and get pods. It will come in handy in a minute. So first, let's start off with existing job, because this is not the stuff that app controller will actually spawn, but the objects that app controller creates can depend on already existing Kubernetes objects. So let's create existing job. Okay, it's actually just, it sleeps for 10 seconds and prints its end. It's not important. The important thing is it will be successful in just a minute. Okay, so this is the stuff that was already in your cluster before you even knew about app controller. So now we create app controller pod, which will run. And we will use it to actually start, stop the whole deployment process, and we will also use another binary that is there that helps us wrap the pod definitions that we already have into the third-party resource definitions. Okay, now we need to create the third-party resource definitions. So right now I'm creating as you can see, third-party resource. I am basically extending Kubernetes API. These numbers here are due to the bug in Kubernetes, which is actually being fixed right now. I'm not sure if fix is already there, but okay, let's not waste time on this. Okay, so I have my endpoints. I have my pod on which the app controller will actually run. So I can start feeding the data into the app controller. So first, I'm gonna create deps. So dependencies are actually it's this stuff, right? It has parent, it has child. So this is what this deployment graph consists of. It's basically the vertices of this deployment graph. Every dependency has one corresponding object there. So it's in Kubernetes now. Next up, I have bare job and pod definitions here. So what I want to do is I want to get these and wrap them into the third-party resources. So I'm doing just that. And then when I get this third-party resource definition, I want to run it in kubectl create, right? So let me just create all of them. So I have several of them. Yeah, I have jobs. Now I'm gonna create pods. Second one. Sorry, before that I demoed it with a smaller amount of pods, and it took faster. So I don't have really anything to talk prepared right now. But we are getting to the end of it. Fifth, sixth one, 7, 8, and 9. Okay, so we actually have all our pods definition. As you can see here, no jobs except for the one that I created by kubectl right from the YAML file were created. No pods were created, and now we can go with kubectl exec Kate's Kubernetes app controller AC run. This is a little bit hacky. The idea is for app controller to have some kind of API, so we can control the deployment process. But for now, it's just run and stop. So let's just run it. Yeah. So as you can see, Eventual Life Pod and Eventual Life Pod 5 are running right now. They're not yet ready because they have readiness probe. As you can see, this is a live pod and this is a live pod 5 right here. Yeah, so they're just gonna run until the readiness probe says they are ready. The readiness probe for them actually looks really it's not complicated. Just wait 30 seconds, echoes OK into the file, and then it just the readiness probe checks if there's anything in this file. Yeah, so as you can see, yeah, they are both ready. So the test job and test job 3 were launched, as you can see in the deployment graph. Test job and test job 3 are right here. Yeah, so I guess you get the idea. When these jobs are actually finished, they should be in just a second. The next parts of the deployment graph will spawn. So there are eventually live pod 3, 4, 5, and test job 4 is also there. So yeah. So we see that pod 3 is ready. So and test job 3 was ready. So test job 4 was created, and we can see in the logs kubectl logs. Yeah, so yes, yes. So from the top, it's as I said, it gets resource definitions. It's getting dependencies. It finds the job definitions and dependencies, and then it creates actual objects. It creates actual objects, and it waits for the dependencies to be met, and when they are actually met, then it creates them. Right? Yeah, and I think it should be done. Oh yeah, no, not everything is ready yet. Yeah, the last pod is actually created, and the pod 9 is running but not ready. It will be in several seconds. Yeah, so the deployment should be done any second now. The cool stuff is that you can actually stop the deployment anytime you want, and because the app controller can use existing data in Kubernetes, it can simply take off when it stopped. So let's just wait. Yeah, so now it should be done. Yeah, you can see it's done. A live pod 9 was created, and it's running in its ready state. So we have everything that we wanted is actually here, and it was deployed in the schedule that it was scheduled in the order that we wanted it to be scheduled in. Yeah, so I can. Oh, sorry. I can actually clean the cluster up. So that's nothing there. Now it will. I will go like really fast. I'm doing the same stuff as before. I need to wait a second because Kubernetes cluster needs several seconds to actually register third-party resource extension. Okay, so kubectl SIG exec stop. Yeah, so it stopped now. I can watch the logs. It stops and it doesn't do anything right now because well, it stopped, and when I run the run, it just takes off, and it will simply it will do the same stuff that we already saw. So I will not bore you with this. Yeah, and that's basically the demo. I know it's really generic. We are currently working on deploying some actual applications that need this kind of stuff. So I hope next week we can have some, for example, OpenStack components deployed using this particular stuff. Yeah, so it can be like become useful, Yeah, I guess that concludes the demo, and if there are any questions, I'm happy to answer them.
Very cool. Does anybody have any questions? If not, I do. So is this in the proposal stage, or are y'all, getting ready to make a pull request or an extension?
Oh, okay. So right now it's completely outside of the core because we were told in this particular issue that we should probably do it outside of the core, or was it in some? Yeah, like right here. So it's currently on Freelance's GitHub. It's like totally open. This is just a pod which you can spawn either as a pod or either as a replication controller if you want some more guarantees about it in Kubernetes. So we don't have any proposal yet. This is just the P.O.C. here. This is what we have, and it would be really nice if we could get it into the main repo somewhere, maybe in the contrib or something like this. But we don't really know yet how to get into the main repository yet. We didn't have plans for this. We just wanted to show it on this meeting and ask what can we do about this. If it's do you think it's worth pursuing it and so on.
Well, yeah, I mean, definitely the spawning dependencies, generating dependencies. That's very important. What do the rest of us think about it? Does anybody have any comments or feedback? You got a cool demo comment from Prashant, +1. Does anybody have any questions?
So this is Matt. I've got a question. When you're working with configuration and configuration change from one dependency to another, but they have shared configuration, have you looked at that problem at all?
Can you repeat it? I'm not sure I get the question. I'm not sure I understand it fully, what you mean.
Say two dependencies have a shared piece of configuration. Have you looked at handling that in this form of manner?
Okay, by dependencies you mean something that's not the dependency inside the app controller, but something that something else is dependent on. Like the parent object in the deployment graph. Is that what you mean?
Yeah, for example, the parent has some configuration it wants to share with a child or multiple children, and then it's not just creating that configuration that's shared, but also making changes to that configuration that's shared.
Okay. We don't have anything for this yet, okay. but this is like really good point, and I think we should look into it. So
yes.
Also, this is not clearly, true, because we can easily work with config maps and update config maps objects from app controllers. So we will still use the default Kubernetes object. So we can do it this way also, and we are also, in Mirantis, we are working hard into improving config maps for more enterprise customers. So the idea for now is that the config maps problem will be addressed by config maps directly. So yeah, this is more or less how the situation looks like currently.
Thanks, Jędrzej.
Sorry,
Yes.
sorry that I jumped into the middle of the discussion.
No. You made a good point. So yes, basically, yes, as Jędrzej said, we can this shared configuration can be just part of the deployment graph. So
yeah, because we don't want to reinvent wheel, so we want to use as much as Kubernetes objects are offering us, and any improvement that should be done to the Kubernetes object should be done into the Kubernetes core within the object, not by app controller itself. Obviously, there may be a situation where we will need to extend to add some custom, I don't know how to name it, but some custom stuff into the app controller itself. But the main idea is to keep as much vanilla Kubernetes as possible and use as much as Kubernetes are offering us. Yeah, I hope it answers your question.
Yes, certainly. I was just curious how you were thinking about it and looking at that problem. So, sounds good.
thanks.
Do you care about namespaces at all? Like, do you deploy any apps and all dependencies in whatever namespace is specified, or?
Yeah. Okay, so the idea is that we can have multiple app controllers in one cluster. Currently, we are using labels for it, but the thing is that when you create your for example pod definitions, you just include the namespace into this definition, and it is created as is. So it just passes through the app controller and it's created as is. The only problem right now is that third-party resources cannot be namespaced. So all, for example, dependencies and all resource definitions have to be in the default namespace, because for now, third-party resources, as I said, cannot be namespaced. But we are thinking about having like separate app controllers. Yeah. We are definitely looking into this.
Okay, cool. Does anybody have any questions before we wrap up this conversation?
Yeah, I wanted to ask about your use of third-party resources. So if I heard correctly, you're storing a little bit of state about the dependencies. Do you happen to use more than one third-party resource?
Yes, we use two kinds of third-party resource. One for dependencies themselves, for the vertices of the deployment graph, and the other one for resource definitions. Because we cannot just create pods, for example, and make them not run. We need to store them somehow, somewhere. Is there a problem with that you know of?
Sure. Not that I know of. I had actually had some trouble on 131. Just creating two or more third-party resources. So
yes, there is a bug about this, and during the demo I was showing a workaround because as you can see, do you still see my screen?
Yeah.
Yeah. Okay. So actually, the problem is that if you use the here is dependencies yum and that's the yeah. So if you use like the same API path, the same API path for two third-party resources, like if I would remove these 1 and 2 here, then it won't work. It's a bug, it is known, and it's being worked on currently. I forgot by who, sorry if you are here. But it's actually being fixed. So this is the problem. So we have a temporary workaround for this, and it works, right? And later when it's fixed, we can just remove everything in our code that depends on it, and just forget that this bug ever existed.
Cool. What version of Kubernetes are you doing this on?
It's like week-old master.
Got it. Okay, cool.
So 1.3 something, I guess, with some additional stuff on it.
Awesome. That's great to know. Thank you.
Welcome. Thanks for the question. So I'm not sure if I still have time because I took already quite a lot.
Yeah, I have a very important question. My question is right now, how can we as Mirantis make it more visible to the community? So what would be the next steps? How can we do it? Because currently we just have open issue, or it's pull request, I don't remember. We had open issue in the features repository. So we wanted to do it in the time frame of 1.4 because it's completely independent from main Kubernetes release. So my question right now is how we can improve visibility of this in the community, or what should be our next steps basically.
Yeah, so I think another thing that we could do is present this at the Kubernetes community meeting, get some time slated for that. Have you already done that, or is this the first POC demo?
No, this is the first POC demo. We just opened. We had opened the issue on features repository. It was recommended for us by Igor Dvoretzky. So yeah, this is the first demo that we are doing for community. So we did nothing yet for community except some OpenStack, SIG OpenStack discussions.
Okay, cool. Can you link us to the place in the repo where you have this open?
Maciej, could you do it?
You mean this one? The app controller stateful app deployments?
Sorry, yeah.
Okay, I'll send it to you.
Great, thanks. Where does your POC live?
It lives on Mirantis GitHub. It's right here.
Yeah, and we obviously like if there is any chance that we can move it into the Kubernetes organization, it would be super cool. And if there is no way,
it's less super cool.
Yeah. So.
Awesome.
Yes.
Yeah. Let's get the links out to these to the issue and to where the code lives to the community, and I can help with that. We'll post it in the minutes. We'll tweet about it. We'll try to get some people on board and get some feedback. Then we can also talk to Sarah about this on the Kubernetes community calendar and seeing what kind of feedback we can get there. So those can be the immediate next steps. Does that sound good?
Yeah, it sounds like a plan.
Sounds great.
Okay.
Yeah.
And, let's go ahead and move on to the next topic. We're running a little bit behind, but if you can stay, please do. If not, that's okay. This will be recorded, so you won't miss anything. Okay, so the next topic of conversation is pet set. Prashant, do you want to take it away? Prashant or Clayton? I think we might have lost him, and that's okay. Mike, are you on? Oh, Prashant's having some audio trouble. Okay, while we figure that out with him in the background, let's hand it over to Mike. Mike, are you around?
Yep.
Okay, great. Do you want to go ahead and give us your quick demo of Nanocube?
Sure. So let me go and share my screen. Can you all see that? Can everyone see that? Yep, let's get it. Cool. Let me drop a link real quick. So Nanocube, here's the link directly. It's on my GitHub. It is a development tool, very much similar to Minikube, if you guys are familiar with Minikube. The only main difference between this and Minikube, for the most part, at least initially, is that it does not require you to run your cluster in a VM. This runs directly on the local machine, whether it be bare metal or the VM. But really, Nanocube is meant to be a developer-friendly way to instantiate a local close cluster of Kubernetes, but also kind of serve as a educational / modeling reference in terms of different ways that you can instantiate Kubernetes. And the two models that you can instantiate Kubernetes with right now are using either traditional binaries, just like you would use any other Linux binary that runs directly on the system itself, or using the self-hosted route that is popping up in other SIG, such as the cluster lifecycle SIG, where this is really using Kubernetes to manage Kubernetes. For the sake of time, you can check out the link there. But you can easily start up a cluster as saying nanocube-t in this case, where we're going to use the binaries directly. And it'll go off in the background and pull. It'll go down and pull down all the expected stuff to instantiate the cluster. It should be up in less than a minute or so. And it does this in a way where you can use sensible defaults with Kubernetes, such as there's TLS enabled with self-signed certs. The configurations used on each of the components are what you would hope to expect in a production-grade cluster. So this is really more about getting a bit more scrappier tool on your hands without so much setup. So now that the cluster is up, it runs off in the background until I send it a SIG term. But I can just go ahead and monitor that the cluster is starting to start up. The DNS is slowly coming up here, so that took less than a minute or so. This is running 1.33. Again, using the traditional binaries through the hyperkube all-in-one binary. So after a couple seconds, this will essentially come up as soon as DNS is available. Give it a couple seconds. But really, this is, again, to showcase that there's multiple ways to use Kubernetes locally. This runs on Ubuntu 16.04 with very little setup. DNS came up. So now that that is up, we can give it an all-in-one example just for the sake of a demo. And let me just show you the status of that real quick. So all the pods are running, as you can see here. If I do a quick curl on the front end, I have the guestbook example up and running. I can delete it just as well, and it goes off and deletes it. So that's using Nanocube quickly with the self-binary mode. As soon as it starts deleting all the other components of the front end, I'm going to rerun Nanocube, but this time using the self-hosted mode. So I send a SIG term here to close it and clean everything up. And once that is ready, I can just pass a -s to say, hey, use the self-hosted mode. In this particular case, it's using static pods in self-hosting, since it's not the fully HA production grade type of setup. But it's more or less to just convey the idea of different ways of deploying Kubernetes, right? The traditional way, or using Kubernetes itself, since it's starting to pop up a lot more. This one will take a little bit longer. It's probably take about a minute and a half as opposed to the 45 seconds that the binary took, because everything is running in a container. But eventually everything will start running within a minute or so, very much like the binaries did. And the expected usage of this is very much how we just saw, right? We're going to expect to see the DNS come up, and we can instantiate a guestbook example. But again, really, it's about giving the developer something quick and scrappy with minimal dependencies to get running, and really to serve as a model to look at different ways of deploying Kubernetes for those of the folks who aren't familiar with the variety. This is starting to come up. Then the API server is coming, waiting for the rest of the components. This takes a little bit longer. Give it a sec. All right, so things are up, and same kind of drill. We're going to wait for the DNS to come up, but for the sake of time, you guys kind of know how that works. So that's Nanocube. It's quick, it's easy. The only main requirement of the machine is Docker itself. I've only tested this on Ubuntu 16.04. Again, I know Minikube is the kind of becoming the de facto in the community, but if folks are out there who don't have the ability to run VMs or don't want that dependency, this gives them an alternative that I think is a smaller code base to convey, at least for initial users, to start getting up and running with Kubernetes. And I will stop right there.
Thanks so much, Mike. You have a question. Does it spin up Kube DNS? Yes.
That is the only add-on right now that I support, but any add-on really can be done. So if I drop this here, I'm going to close it real quick. You can see the code base in add-ons. It's going to create right now DNS, so it creates that onto the cluster itself directly. Obviously, you can add the dashboard and others, but yes, DNS is supported.
Awesome. Thank you so much. Does anybody have any questions for Mike? Okay, great. Thanks again, Mike. I'm going to drop a link in from Prashant. Audio isn't working. there's a discussion going on about creating a catalog where people can put examples of stateful apps. This will help Prashant with making sure that there are no breaking changes going into beta, no major feature requests required. So please take a look at that thread if you're interested, and we'll set some time aside next week for him to speak to us about that. Does anybody have anything last minute that they want to talk about or ask? Okay, thanks for joining us today. This will be recorded and posted, and the minutes will be posted with all of the links, and we'll see you next week.